Hi again. So this is the exercise problem 4.94 in which we are asked to use the superposition theorem to solve for I naught, which is this current, and V naught, which is the voltage here across the 20 ohm resistor in the circuit of figure 4.94. So this is the circuit of figure 4.94, and here we have to find the value of I naught and V naught by using the superposition theorem. So in superposition theorem, what we have to do, we have to consider each of the sources in a circuit one by one, finding the values of the current and voltages from which are developed across the elements by using the sources, and then adding the effect of each source at the end of the problem. Okay, so now let us consider first this voltage source and representing the current source with its internal resistance here. So as we are considering the ideal current source here and the ideal voltage source here, so the internal resistance of the ideal voltage source is always 0, while the internal resistance of an ideal current source is always infinite. So now considering the voltage source, okay, in this question, so let me consider the voltage source, and the circuit here will become like this is the 10 volts voltage, this is the same resistance, this is the resistance of 20 ohm, this is the 60 ohm, or let me use it downwards here, this is the 60 ohm here, this is now the open circuit, that is the other portion of this circuit in which this is the 5 ohm resistor, or again now let me use 5 ohm here, 10 ohm here, and this is the 45 ohm resistor. Okay, so now that is the circuit in which we can very easily see that these two portions are now separated from each other, and it can be clearly seen here that these two resistances are in series with each other. Similarly, these two are in series and in parallel with this circuit. So in transforming this one, we can easily see that, let me draw it again, we can very easily see here that the circuit here will be like this one. This is my 10 volts source, this is the 60 ohm resistor, this is the 20 ohm. Similarly here we have this is the 45 ohm resistor, this one here. Okay, so that is now the 10 ohm resistor. The other branch here consists of two 5 ohm resistors which are connected in series with each other. So that is the scenario now. Okay, we can very easily see that this is the scenario, and we have to find the value of I naught here and the value of V naught here. So that is the scenario. Let me simplify it by using the same steps here. So this voltage source is now can be seen that this is in parallel with these two branches. So again now this one, so here this one, and the same branch is now connected here. Okay, so this is the circuit in which this is 10, this is 5, this is 5, this is 60, this is 20, this is the 10 volts voltage source, and similarly this one is here. Okay, so if I can write it, this is in series with these two resistors, so that is the 45 ohm resistor. Okay, so that is the scenario now. And now simplifying it again, and in this time I will have the simplified version, and this simplified version will be composed of this voltage source, this resistor here, this 45 ohm resistor with this 10 ohm, and 5 plus 5 is 10 again, so that is now 10, and that is the 45, and the current here is I naught, and here the voltage is, this is 20, this is 60. Okay, and the value here is V naught, that is the 10 volts resistor. What we have to find out, we have to find out the value of I naught, and let me call it I naught prime, and this is V naught prime. Okay, so we have to find out the values of I naught prime and V naught prime, and these are the two resistors, and the parallel combination of two same resistor will be the half of one of them. So half of any one of them will be here, this will be here 45, here it will be 5 ohm. Okay, so that is 60, that is 20, and the polarity here is this one, this is V naught prime, and the current here is I naught prime, and the value of this voltage source is 10 volts. Okay, so let me represent this I naught by red and this V naught by red as well. Okay, so now in order to find the value of this I naught prime here, I can very easily see that the value of the voltage here at this branch is already known, and that is 10 volts. Okay, so the value of this voltage is already known, and that is 10 volts divided by 45 plus 5, because these two are in series with each other, so that would be 50. Here I will have 1 by 5, so 1 by 5 is equal to 0.5 amperes. Okay, so that is the value of I naught prime. Similarly here we can again see, let me represent it with green color here. Okay, so V naught is represented by the green color here, so we can simply here see that these two branches are again connected here, and the value here is again 10 volts. Okay, so across this all branch again the value of voltage is 10 volts. These two are in series, so as these two are in series we can very easily apply the voltage divider law here, and in applying the voltage divider law, the value across 20 will be 20 ohm will be 20 divided by 20 plus 60 multiplied by 10, that would be 20 by 80 equal to the 10, so multiplied by 10, sorry, so that would be this, and here I will get 2.5 volts. Okay, so the value of V20 is 2.5 volts. Similarly the value of V naught prime, we can see the polarity here, that the polarity of V20 and V naught prime are opposite to each other, so that is minus V20, and the value of V naught prime is minus 2.5 volts. Okay, so the value of V naught prime is this one, and the value of I naught prime is this one. This is the case when only the voltage source is considered in this circuit. Similarly, now let us assume the current source here. So assuming the current source here, we have to represent the voltage source by its internal resistance, and the internal resistance of the ideal voltage source is always 0, as I have mentioned earlier on. So now representing this one with the, this is B, and considering the current source. Okay, so in considering the current source, the circuit I have will be like, here we will have a short circuit and this current source will act as the prime power source here. Okay, so applying this circuit here, what will I have? This one, and here the current source is connected, this one. Okay, this is the case, and the value of this resistor 45, the current source is of 2 amperes. This is 5, 5, 10, this one is 20. Okay, and as the voltage source is neglected here, so here it is represented by its internal resistance, so that is 60, and we have to find here the value of I naught, and let me call it I naught double prime. Here let me call this V naught double prime. Okay, so that is the circuit now here, in which we have to find all the values. So here we can very easily see that this one is the delta representation here. Okay, so before using the conventional methods of solving this circuit, we can apply the node analysis here, the loop analysis here, but we can already see here that in applying the node voltage method, we have to identify the number of nodes, and we can very easily see that the number of nodes here are 5, in which when one will be considered as a reference node, we have to make 4 equations. Okay, and then solving the 4 equations will be very hard. Similarly, in identifying the meshes here or loops here, we have total 4 meshes, and applying the currents there and then solving that circuit will also be very hard for us. Okay, so now using the conventional methods here, in using the conventional methods, that would be the case here, that this one, and this one, these are my resistors. Similarly, this one here is the okay, so that is the case now. 2 amperes, 45, 60, 5, 5, 10, and that is 20. Okay, so now that is the circuit which we have. So now converting this delta circuit into the star circuit, so in converting this delta circuit into the star, this will be the case, and here let me call it A, this is B, and this is C. So the value of A will be equal to the product of the 2 resistors, so that would be 50 divided by the summation of 10 plus 10, 5 and 5, and that would be 20. So here we will have 2.5 ohm. The value of B here, the 2 resistors connected here are again the same one, so 50 divided by 20, that is again 2.5 ohm, and the value of C here is that these two, so the connected resistors are 5 and 5, so 25 divided by 20, that would be equal to the 1.25 ohm. Okay, so now representing these one by their, okay, so let me remove them. Okay, so that would be the case here. So now here this one is 2 so that one is, I think this is C, which is 1.25, this is 2.5, and this one is also 2.5. okay, so now let me draw it clearly here. So drawing it clearly, I can see here that this will be like this one. Okay, this one, this one, this. Okay, so you can very easily see here that this is 2.5, this is 45, this is also 2.5, this is 1.25, and this one is the 2 amps. This is 20, this is 60, and this is I naught double prime, which I have to find out, and this is V naught double prime. Okay, and these are connected with each other. We can easily see that the 45 ohm and 2.5 ohm, these are in series with each other. So adding them together, I will get here 47.5. okay, so this, and then this 2.5 here, this one, this one, these two, we can very easily see that their both ends are connected, so these are in parallel with each other. Okay, these are in parallel with each other, and similarly this is connected with this one. Okay, so now 47.5, 2.5 is here. So now again, this is the 2 amps, this is 1.25, this is 20, and this is 60. Okay, so these are the two resistors, and also I can draw these two like, if you can see here, these two can also be drawn like this one here. This one is the resistor, which is 1.25, this is 47.5. you can easily see that I am not doing anything, but I am just representing them in the manner which will be easier for us to comprehend. Okay, so now here, this one, and as these two are in parallel and also parallel with this one, so the same current is flowing, will reach here and then divided into both the currents here. So this, the same current here. Okay, so this, and similarly the 2.5 ohm resistor, this is the 60, this is 20, and I have to find this voltage, which is here V naught double prime, and I have to find this current, which is here I naught double prime. Okay, so now how to find the values here? Let me have the source, which is the 2 ampere source here. So in order to find the value of V naught double prime here, let me find the value of V20 here, which is in parallel with the 6 ohm resistor. So here we can very easily see that the value of V20 is equal to the current I20 multiplied by the value of the resistance, which is the 20 ohms. So but we don't know the value of I20, which is flowing through this resistor here, and we can easily see that the value of the source current here is 2 amps, from which I have to find out the value of I20, which is in parallel with the 60 ohm resistor. So I can very easily use the current divider law. Okay, So according to the current divider law, the value of the current I20 will be equal to the value of the resistance, which is in parallel with the resistor through which we have to find the current, divided by the sum of the resistances which are in parallel multiplied by the source current. So here it would be 60 divided by 80 multiplied by 2. These two will cancel out, 2 4. So here I will have 1.5 amperes. Okay, so 1.5 amperes is the current. Similarly, the value of V20 here will be equal to, and the polarity of V20 will be like this one, and it will be 1.5 multiplied by 20, and here we will have 30 volts. Okay, so that is the value of V20, which has the polarity like this one. But we can very easily see that we have to find out the value of V naught double prime, and the polarity of the V naught double prime is opposite as that of V20. So therefore the value of V naught double prime is minus 30 volts. Okay, so now that is the answer of V naught double prime, which is the value of the V naught when only the current source is considered, while the voltage source is represented with its internal resistance. Okay, so now in order to find the value of the current, which is here I naught double prime, so that is the current which is I naught double prime. Here we can very easily see that this is the current which is coming here, this is also the current which is here, the value of it is 2.5, sorry. So these two are, let me call it 2.5 here, and the source current is this 2 amperes. So again, in order to find the value of I naught double prime, we can use the concept of current divider law. So the value of I naught double prime here will be equal to the value of the opposite resistor, because 47.5 and 2.5 are in parallel. So 2.5 divided by 2.5 plus 47.5 multiplied by the source current, which is 2 here. So here 2.5 divided by 50 multiplied by 2 here, so 2 will be cancelled with this one. So 2.5 divided by 25, here I will get 1 by 10, so it will be equal to 0.1 amperes. So that is the value of I naught double prime. Okay, so that is that are the values when only the current source was considered. Similarly, we have also found out the values of the voltage and current when the voltage source was considered and current source was neglected. Okay, so now in order to calculate the values here, let me calculate the value of voltage here first. So the value of voltage V naught will be equal to the value of the voltage when only the voltage source was considered, and the value of the voltage when only the current source was considered. So the value of V naught prime was equal to 2.5. It was minus 2.5, and similarly the value of V naught double prime was minus 30. So adding them together I will get minus 32.5 volts, and that is the answer of V naught. Okay, similarly, in order to find the value of I naught, let me use the currents I naught prime and I naught double prime here. The value of I naught prime was 0.2, the value of I naught double prime was 0.1. so here the value of I naught is 0.3 amperes, and that is the answer of I naught. Okay, so by using the superposition theorem, we have find out all the values which were asked to find here. Okay, so that is the superposition theorem, and I hope by solving this question all the concepts related to the superposition theorem will get stronger in your mind. Okay, thank you so much, and I will see you some more questions, some more tricks in our upcoming videos. Thank you so much, and take care of yourself.